In this lesson, we'll go over an example to illustrate the use of Lamy's theorem. In this example, you have a particle shown in blue color which is situated at origin. And on this particle, you have three forces P bar, Q bar and R bar are acting on, and they are maintaining it in equilibrium. We know the magnitude of one of the forces P, which is 1000 newtons, and we know all the angles. For example, this angle is 60 degrees and this angle is 45 degrees, and these two angles are 90. The angle here and the angle here are 90 degrees. So we know magnitude of one force, we know all the angles, and we are required to find out the magnitudes of the other two forces, which is a perfect example for application of Lamy's theorem. However, note one small detail. The detail is that in this example, the force Q bar is directed towards the particle. Similarly, the force R bar is directed towards the particle, and force P bar is directed towards the particle. Whereas for application of Lamy's theorem, we would want that the forces be directed away from the particle. We would want to have the forces appearing somewhat like this: P bar, Q bar and R bar. Okay, so we would want P to be somewhat like this, Q to be somewhat like this, and R to be somewhat like this. We want P bar, Q bar and R bar to be like this. This can be very easily achieved. For example, you can move the point of application of P, which is here, and move it to somewhere here, so that P would be acting upwards, and say this is P bar to be specific. Similarly, move the point of application of Q so that Q appears like this. Similarly, move R so that R appears like this. This we can do because we have principle of transmissibility. The forces are transmissible along their lines of action. And then find all the angles. For example, you have this angle and this angle, they are equal, so I can mark 45 degrees here. See, once this is 45 degrees, since the total angle is 90 degrees, I can mark this angle as 45 degrees. I have angle between this line and this line, I can mark it as 60 degrees. Once this is 60 degrees, you have this to be 30 degrees. So all the angles are marked. Now to find the angle between, let us say, P and Q, this is P and this is Q, this line is Q, and this line is the line of action of force P now. So the angle between them is 45 plus 45. You have 45 here, you have 45 here, you have 30 degrees here. So this angle is, you have 120 degrees. Similarly, the angle between P bar and this R which is transmitted along the line of action, this R bar, you can find out to be 45 plus 30 plus 60 degrees. 60 plus 30 plus 45. So this is 5, 6 plus 4, 10, it's 1, 135. This angle you can find as 135 degrees. Similarly, the angle between Q and R is 60 degrees plus 45 degrees, that is 105 degrees. Just to make sure that we are computing the angles correctly, sum of the angles 120, 135 and 105. Okay, 5 plus 5, 10, 0, 1, it is 6, 360 degrees. These three sum to be 360 degrees, so probably we did right. And now we can apply your Lami's theorem. To say that P by sine 105 is equal to Q by sine 135 is equal to R by, you have R by sine 120 degrees. So each force is proportional to sine of angle between the other two forces. That's what exactly we have done. Magnitude of force P is proportional to angle between Q and R, 105. Similarly, magnitude of Q is proportional to sine of angle between the other two forces P and R. Similarly, magnitude of R is proportional to sine of angle between the other two forces, of which we know this P is given to be 1000 newtons. So we can write Q is equal to 1000 divided by sine 105 into sine 135. Okay, and we can quickly bring up a calculator to do this task. Okay, this 1000 divided by sine 105 multiplied by you have this equal to 732. This is approximately equal to 732 newtons. Similarly, the magnitude of R is given by 1000 by sine 105 into sine 120. This is equal to, let us try to bring up the calculator again. Okay, I should have saved it earlier, but that's fine. 1000 divided by 105 sine multiplied by 120 sine equal to, you have, this is approximately equal to 896.57. Okay, so if the forces Q and R need to maintain, forces P, Q, R need to maintain the particle at Q in equilibrium, you need to have magnitude of Q as 732 and R to be 896.57. Most of the problems that involve using Lami's theorem, they involve three forces. All the three forces are concurrent. Typically we know the magnitude of one of the forces and all the angles, and you will be required to find the magnitudes of other forces. One key point you need to remember is that the forces need to be away from the particle in question, as shown here. That is, all the tails of the forces, they meet at one point, and then measure the angles and then use the Lami's theorem. We'll try to see a few more examples and other topics in subsequent lessons.